Welcome to another test and teardown video. Yep, it's another wave analyzer from HP. This one is called a model 310A, and according to the manual it says 1 kilohertz or 1 kilohertz, but 1.5 megahertz. So how is that possible? So I don't know. How the heck is that possible? Because of that, right? But this is really sexy, this meter here, and the resolution here. I can't wait to play with that. Some zero set. We also got the detector output, a recorder output. I was reading a little bit about this automatic frequency control. That is a cool feature because when you're running in narrow bandwidth, it is a pain to adjust the accuracy of your operating frequency. And then you can go to automatic frequency control, and then it will auto track and continue to measure even if your input frequency is changing all the way up to 100 hertz per second. Then it will just auto track. So how is that done? Is there like a motor controlling this, or is it purely electronic, or how is this? So yeah, absolute relative, great input. I think we're just gonna go and put it on the table and test it. The thing is 44 lbs, so that is 21 kilos. So that is a little bit heavy. Let's look on the rear plate of this fantastic unit. Oh, it's a little bit loose here. Fuse is okay. And it's set for 230, so that is great. Oh, look at this funny detail. There's a sticker here about 365 days of warranty, 2,000 hours, and it's terminating in 1970. So that means we actually know this unit was purchased in 1969, and that is a fact. So that's pretty funny. By the way, I just happen to have one of them connectors for this funny connector here. Yeah, a mating connector. But what the heck is this called? Because I'm not able to find a new one, and this one is a little bit crusty, but still it works. But I would really like to get a new one, or a better one. And I don't want to replace the connectors here. I want to keep everything as original as possible. Yeah, okay. Yeah, it still kind of works. I think we're ready to power up this thing. So let's apply mains, so nothing bad happened. Ooh. And of course this is a transistor only product, so that means, wow, that means no warm-up time or anything. Wow, I love this. See, that must be some bulbs or something. That is sexy. But we got full cal. Oh. Why is this? That is weird. This is a little bit loosey, but I kind of did not expect this to happen. And then, okay, so it's cal what? And then this goes off. Okay, normal bandwidth, But this can't be good. Okay. Is it the usual switch kind of thing? I don't. What? What have we got here? I don't know. I need to play a little bit more with this, but there's definitely... See? This tells me we got a leaky capacitor somewhere because it's just coming. It's probably gonna be better and better and better and better. This is a classical leaky capacitor, and it's has nothing to do with the input. So there's definitely a problem to solve before we can play with it. I will let it run a little bit and then try and input something and maybe come back in a minute. Look at that. So now I'm inputting a 10 kilohertz signal. And I figured out this is the zero adjust for the frequency readout. So now you can calibrate, and when I move the frequency, see? And I put this to 3 kilohertz of bandwidth, right? So see, it actually works, right? 1.5 each way. Isn't that cool? So the frequency readouts perfectly fine. So now I can go and see my 10 kilohertz signal, and then I can go up in frequency to 20. See, have I got any harmonics? And then I can, of course, oh yeah, this is what I need to do, right? Ooh, we need to fix this pot, and then try and search for the harmonic. Yep, here we go. This is of course the main frequency. So there's, oh yeah, here we go. Where is the harmonic? Ah, maybe it's a third. It's a little bit, no? I don't see anything. That's pretty cool. But of course I'm inputting a nice sine wave. I think there's, see, now there is a connection. Yep. Oh, I don't know exactly what to say. I think we need to clean the switches and stuff all over the place, but and also the output is full of some really weird things. Let me go back to 10 and let's dial this down to 0. Look at that. We got some really funny interference, and I think it's, see, this is the BFO, so that is the internal oscillator that it uses to mix everything with. So now you can see that, and it's also modulated with some instabilities. And if I go back to my normal, see this really weird modulation that you see here, and it's, see here my 0, and it's not mains frequency, it's something else. And even if I remove my input, see, it's still there, and it's not supposed to be there. So there's a BFO leak. See, this is the BFO. That's exactly what's leaking. And so there's a mixer fault or a transistor in the mixer system that is probably dead. It could be cool to see if we can find the error. Yeah, that was a frequency. Anyway, this beautiful unit seems to be at least a little bit alive, and it's using the correct power, about 17 watts. What is it? I saw the label here says 16. I think that is close enough, but let's look inside. we are inside, and of course this is a transistor unit, so the mains transformator will be such a tiny little one. That is nice. So why is this unit so huge and heavy? I don't know yet, but I think it's because everything is built like a tank as usual. HP only do it right. Look at that. The gearbox here is humongous, and everything is done in thick, what is that, 5mm thick aluminium wheels, and they didn't really try to make it lightweight. All this is cast in one piece, I guess. Again, like 3 or 4mm thick aluminium stuff. So that will be the frequency synthesizer generator stuff, done in super sexy style. And all the LEDs of the front panel, they're really nicely in here. So to be able to change this, you need to take off the front panel, I guess, but everything is working so far on the LEDs. We got a wire here very close to. Okay, yeah, we need to open some of these cans and see. And this is only the top half. See, we're only halfway down here. So there's plenty of more. I also wanted to measure the power supply for stability and voltages and stuff. That is a good place to start. Here's the little trick I do sometimes. When I pull apart stuff, I need to play with this for a couple of days. I add some little secret marks. So now I can easily put this back and also hide the text when it is assembled again. And the same with this. See, a little secret mark. And what do you know? This is the crystal oscillator for the BFO, and I think this is actually the oscillator option. So this board will be an option, but isn't it? Oh, it's too tight. To pull out with one hand. I just wanted to show you guys this transparent crystal. That's beautiful. USB frequency adjustment, LSB, yada yada, tune this and tune that. It is beautiful. Not that many transistors. What, only 3? Handwritten number on the glass. Oh, that is so sexy. Oh, serial number handwritten here on the PCB. Oh, nice. And in here we have another module, also with a crystal oscillator on it. Some more tune and oscillator level and tune this and that. Ooh, it's beautiful. But look at this. The trimmer here for oscillator level. Look, it is one of them trimmers with a switch built into it. Right? But let's look at the switch. It's shorted. So they knew already from the beginning they're not supposed to use the switch. So why the heck are they having this one? Maybe it's because it's much more stable when you push from the top. But still, yeah. Beautiful PCBs, and nothing is too tight or anything. There's plenty of space around everything. Beautiful. So this is the bottom part of the unit. This plate down here is about middle of the unit. So it's divided in 2 halves like this. We got some really cool looking units here. maybe some active units. I'm a little bit unsure about exactly what they do. Those two look identical, and it seems from the text on it, break some thing. I don't know exactly what that is. I think we need to consult the manual for that. That would be a low pass filter like this one. So I guess if we take this out, there will be a trimmer to fine tune this filter. We see some really big capacitors all over this unit. So they do take filtering, power supplies and stuff like that pretty serious. Also, if we look inside, everything is neatly packed into small compartments, and they're putting on nice text, so it's easy to figure out what is what. I really like this design style. Of course, it's not compact in any way. If we look at this huge area, we just see like 4 PCBs, and of course it's 90% air, so this could have been a lot smaller, this whole unit. And here is the filter bandwidth selector, so that is why I think we got some filters here where we select the different filter path through these different filters. And this is the different filter systems as well, and it goes all the way to the very back. Neatly made. And another little metal canned box. Oh yeah. Let me see if I can get some more light down here. It is just fantastic, this gearbox. Doesn't matter how fast or how slow you move the gear here, the feel is just fantastic. See how much this is geared for some thick, heavy, solid. I don't think we can get easily into. Yes, we can. We can take this out and have a look. So now we're inside the tuning, and if we look in here, we will see a very big capacitor, variable capacitor, inside all this oscillator tuning stuff. I don't know exactly why I got this big inductor here, but that is probably a good explain for this. In the schematics, some diodes and just one little transistor, and that's kind of what it is. And then it goes into this box, and that is called local oscillator amp and input mixer. So this is where it mixes this oscillator with the input signal. Alright, and then it goes to some other stuff and then so on. Yeah. Oh, I saw, by the way, down here, a really cute relay. See this metal? I don't know how easy that is to see. Now it's easier to see. On a lot of transistors. Ooh, those two are dangerously close. But they don't touch. But that's a pretty cute relay. And again, they're using those trimmers. And again, see, they're not using the switch in them. So it's definitely for mechanical stability, because they are a lot better over the conventional type. When you push them a little bit, they just bend, and this is really annoying. But this is a much better solution. They are really nice and stable. But of course they come with an on-off switch. That's just the way it is. Who cares? The mechanical problem is solved. Now I've been cleaning all switches. I had all boards up, cleaned all contacts of all boards and pulled them in and out a few times. There are actually a few boards in this unit you can swap. Mechanically, you can swap them. And there's others where they intentionally moved the connector, so there's no way you can swap them. So that is something to be very aware of. I'm really surprised to see that actually in a unit from HP, to be honest. So let's see how things turns out now. So this is my input. See, if I turn the input 10 dB up and down, the meter also goes more or less 10 dB up and down. So now it's 10 dB less. Let's crank up to 10 dB here. So it seems to be a lot more accurate. So this is the thing when you're doing measurements with all those wave analyzers. Correct input, and then adjust for 0 at your base frequency. Set the bandwidth. We're not gonna go super accurate. Okay, and then we fine tune for the frequency. So that is my frequency, 10 kilohertz. What I'm doing now is a 10 kilohertz square wave. So now it's not a sine wave anymore. So now we're gonna see something funny because now I have a lot of harmonics, right? So let me crank up the detector up to 20 kilohertz. See? Nothing. But what do you expect is gonna happen at 30? Ooh, you're gonna see 10 dB. Isn't that fantastic? See? So this is the third harmonic. So let's continue a little bit to 50. Ooh, see? And then we can crank up the sensitivity 10 dB. All right, let's go up again. So again, at 60, it's an even, so we don't see that. And then, so yes, again. Isn't this just cool? So we're gonna see all the harmonics all the way up. And this is almost like a spectrum analyzer. All you have to do is, okay, you have to dial the frequencies yourselves and plot the levels, but hey, this is 1960, right? And we get all the values. Now we can crank it up 20 dB. And we can just carry on forever and ever and see all the harmonics. And of course, if I put in a sine wave, none of this is gonna happen. I also really like this meter with the indication signal. Let me turn off the light. See, it's, here we go. This is really, really nice, and it's super easy to use, you know. Where are you and what are you doing? Yeah, I really like this meter. It's super great and easy to use now when it's actually doing its thing. So I'm gonna put this together again.